Hello, on this video I will introduce the ActiveRecord Query Interface. These slides are heavily based on the Ruby on Rails guides, the official ones. So please, after watching this video, I encourage you to read through the guides all the sections there are regarding queries. So, alright, to get started, ActiveRecord will provide a query interface that enables retrieving models from the database. The interface methods are available to any model class that inherits from application record. Many of the possible queries that are available quite resemble what you already know from SQL. So there are queries that allow you to retrieve single and multiple objects. There are conditionals. Conditionals commonly used on where clauses in SQL. You also use them here. You got ordering, either in ascending or descending order. You can group results. You can use the having clause. You can limit and offset. You can pretty much do everything you already know from SQL with ActiveRecord. Instead of manipulating, interacting with the database directly, rather than that, you use objects. That is ActiveRecord models, of course. So first of all, in order to establish whether a given object exists, a given model exists given its ID, there's a method called exists with a question mark at the end. So you can simply call client.exists, ask for the first ID, it will tell you whether that record exists or not. You can also pass a list of IDs, or you can even ask for a different attribute, such as a name. In addition to exists, there are other methods, such as any and many, that will tell you whether there's any record. For instance, below you see article.any, that will ask whether there are any articles in the articles table, or whether there are many articles instead of just one or none. So that's, I think, the most basic thing you can ask ActiveRecord about, whether a record exists or not. Then, if you'd like to retrieve models, you got the find methods. So the first version of find, basically you give it an ID parameter and it will give you back the object with the matching ID. The second version we see here will receive an array with IDs. It will find all matching objects with the IDs that are contained in the parameter. There's the take method that will retrieve a record in no particular order. Just will take any record. You can also ask take to give you more than one record. Below you see the example. The first method, you've seen it many times because I've used it extensively in my demonstrations. You see it works pretty much the same as the methods I already showed you. You can ask for the first client, that will give you the first ID available, the first ID in the table, actually. And if you ask for the first three, well, it will give you the first three IDs in the table. Then you got pretty much the same thing for last. You can ask for the last the client with the last ID in the table in these examples, or you can also ask for the last three IDs in the table. Result collections can be ordered by using the order method. The method can be combined with the methods just seen. By default, order will order in descending order. You see here. Client.order, first name last, and below you see the matching SQL statement. So it will select from clients ordering by first name in descending order, and will limit we'll take the last. Then you got the find by method that will retrieve the first record matching some conditions. You can, for instance, specify a value for a particular column, a particular attribute, such as first name. There's a bang version of find by that you call with an exclamation mark, as you see below. You pass the parameter, you pass the attribute name together with some. The example here uses does not exist as a first name. Of course, that first name will not exist in the table. Therefore, an exception will raise. Will be a record not found exception. It is also possible to retrieve large sets of records efficiently. You use for that define each and find in batches methods. This is necessary because if you simply ask for all records, like in the example here, all user.all will load all of the objects into memory. And it may happen that there's not sufficient memory to load an entire table in of the database. So it's much more efficient to progressively ask for the records you need while iterating, while traversing the entire list, the entire table with the records. So we'll see both methods, define each and find in batches. Define each will basically retrieve users in batches of thousands and yield them to the block one by one. So that's way more memory efficient than retrieving the entire table and putting the entire table in memory and then iterating over the records in memory. Then you got the finding batches. I'll go back for a second. Here with find each, you see that it will retrieve users in batches of thousands and yield them to the block one by one. Okay, one by one. In the case of finding batches, it will basically give you an array with 1,000 invoices at a time, and then you can you can take that invoices variable, which will contain an array, and then you can do something to that array, right? So for further details about model retrieval, please have a look at the Ruby on Rails ActiveRecord Querying Guide, sections 1.1 and 1.2. There are other subtleties I'm not covering here for the sake of time. So if you'd like to apply conditions to your queries, you can use the where method, which behaves quite similar to the SQL equivalent SQL statement. You see below there's an example that will basically find some client where the orders count matches some parameter, right? So you basically call where, you put whatever column you want to use for the condition, then you use an exclamation, a question mark, where you intend to put the value with which to complete the condition. You can have even composite conditions as below. You got orders count and you got locked. Right after the string containing the condition for where, you put a list of parameters, a list of variables, a list of values that will be replaced, that will replace these question marks that are in the condition statement. Well, you can even use sort of keys as it appears here. You got client word, and you got the query, you got the condition. So created at greater or equal than some start date, and created at less or equal than some end date, both with a kind of symbol notation, if you will. And after that, what appears right next to the condition string is a hash. You see, there's a hash with key start date, with and another key end date, and the values for these keys are the start date and end date for the condition. So you can use placeholders in the condition as shown here above. Or you could also pass in as parameters hash conditions, such as in the example what says locked true. Locked colon true, that's a hash condition, a simple hash containing just one key and one value. And well, you can also give something more complex, such as below. You got a range created at. You got a time now midnight minus 1 day. Until now, midnight. That is midnight today. So in the last 24 hours or so. All right. So if you like to use some subset conditioning, such as this, you got orders count 135. You got equivalent SQL, and you realize that you're basically filtering by clients that have 1, 3, or 5 orders, basically. So you got clients orders count in 135. So it's quite intuitive to use conditions, as it is very similar to just regular SQL. The different thing is that here you'll be replacing those question marks with actual values that come from variables, that come from parameters of your method or constants. Right. There's a possibility also to specify, to negate, to have a not condition. You'd like clients that are not locked, basically. And that translates to the SQL below. You got a selection from clients where clients are not locked. Or conditions can be specified by calling on the first relation and passing the second one as an argument, as you see here. So there are two where operations going on, right? The first one will take the customers that are locked, and the second one will take the customers that have 1, 3, or 5 orders. So you got the OR method call, sort of giving you, as a result, the set of clients that comply, that fulfill either condition, or both. And you see the SQL below matching these two operations, these two where operations. You see there's an OR statement in the SQL below. Now, as for ordering, yes, you can have ascending or descending ordering. You simply call the order method, passing the attribute by which you want to order. You can order descendingly or ascendingly. Well, what else? You can order by multiple fields, the column names and ordering options. You pass them as parameters, like in these examples. Well, you got the select method, which will basically take some of the columns, right? Thinking it in the way in which select statement works in a regular database. Select statement will receive either an asterisk or all columns, or a set of columns. So select here behaves pretty much the same. You have to specify which attributes you're interested on. That means that the records will be retrieved from the database only consisting of those columns. The resulting model objects will only contain the selected data, the selected attributes, and not more than that. So one has to be very careful, because if you only select a few columns and you try to access a column that has not been, an attribute that has not been initialized in the model, then an exception will be raised, the missing attribute error exception. So you have to be very careful when you use select for that reason. You will sort of load the objects in an incomplete way. You'll get the objects only with the columns you specify. So you have to know what you're doing when you use select. Sometimes you'd like to retrieve the distinct values of an attribute, and you can do that placing a call to distinct right after the select. For instance, if you'd like to get the distinct client names, you can do so as in the first example, and that will translate to a pretty obvious SQL below. So it is even possible to remove the uniqueness constraint once the query has returned, as you see in the last example, right? So first, distinct is called. Then you can get all names, even if there are duplicates, by calling again query.distinct false. It is possible to limit the number of records returned by invoking the limit method, as in here. You got client limit 5. That means that it will just return 5 clients. You can use this after a select, for instance, after a find by. You know, you have many different uses for limit depending on the case. Then you got the offset operation. The offset operation will skip to some record you specify, right? So this will, in the last example, will result in getting a maximum of 5 clients beginning with the 31st. So it will jump to 31st until the 36th. 35th, really, not 36th. All right, then we got a group operation. You can you can combine this with a select if you need. You can group your models, for instance, by some date or by some name. Having this models grouped, then you can apply aggregate operations such as sum. Here we're getting the sum of prices. We're getting the order date, the total price of the order. Then we are grouping by the date, the creation date. The total number of group items can be obtained by calling count after group. So here you got a hashback that tells you that there are 7 awaiting approval and 12 orders that have been paid. And the equivalent SQL below. It's all very intuitive so far. It's just the same as SQL. You got a having clause, which is commonly used in SQL with a group by. You can also use that with active record queries like this, as shown here. Finally, we've got the join operations. This is perhaps the most complex part. This is part I wanted to get to because it's the most common you'll be using normally in your project, and even it is possible that in the current assignment. The current assignment you got in the lab will require you to perform quite a few join queries. So join queries can be performed in many different ways. You got a possibility to just pass along a SQL fragment, a regular SQL fragment. You can also pass hashes of named associations. You can join using multiple associations, and you can also use nested associations. The last case is perhaps the most important. All right, the first case. We got the plain SQL. So you see here that you'd like to perform a join involving authors and posts. So you'd like to get all posts from authors, right? Sorry, you'd like to get all authors that have posts published. That's the semantics of this query, right? So you got authors joins, inner join posts on post author ID equals author ID and posts published true or T, whatever is that means. So I guess that means the posts are published. So you want to get all authors that have published posts. Then if you'd like to use the more idiomatic Ruby-based kind of syntax for joins, it is convenient to have a look first at the example we've got here. We've got some few example models that are, of course, associated with one another. So you got category that has many articles, and you got articles that belong to a category that have many comments, have many tags. Then you got a comment that belongs to some article and has one guest who has written the comment. Then you got a guest that belongs to some comment, and you got a tag that belongs to an article. So, right, if you'd like to get all categories for which there are related articles, you can use a join, a very simple join such as this. You simply call joins passing the name of the association. And in the case of join, you pass the name of the association. And so a category has many articles. So you want the join to give you all categories for which there are related articles, and that will translate in the SQL below. Note that categories may appear many times, as there can be many articles associated with a category, and the category will have many articles. So per article, the category will appear. So if you'd like the unique names of categories, then what you use is to apply a distinct method call at the end after calling the join, as you see below. Right, then you can have multiple associations. For instance, article. If you go to article, let's remember it belongs to a category. It has many comments and many tags. So you can join with a category and you can join with comments, and therefore you will get all articles which have a category and have at least one comment by calling joins on the category and comments associations. Remember that parameters for join are association names. So in order to perform a join, you must be very careful with the associations that are specified in your models. You have to make sure that the associations exist first, right? If you don't have associations in your models, you won't be able to perform these join operations on your models. All right, so we've got this last kind of join association which has multiple levels, that is nested kind of join. So in this case, we'd like to retrieve all articles that have a category, have comments written by guests, and have tags. And these can be retrieved by using this join query here. So you got category joins, you got articles, and you see articles is a key. Then the value is an array with square brackets. Inside that array, you got two objects. The first one is a hash. You see comments, colon, guest. So internally, that's a hash. And after that hash, you got a second value that is tags. And you see how that translates to SQL below. You see that there is a join among article and comment, and another join among article and tag. And of course, another join among comments and guest. So recall that the association names are used here. You see, if you see that there are, how do you say, if you got singular naming for the association, that means that it is possible that there's a has one association. If we go back and look at the guest, perhaps we'll be able to make sense about this. Yes, if you look at the comment, you see that a comment has one guest. Therefore, the name of the association here is singular. That's the explanation. That's the reason. And lastly, to compute calculations, you can compute calculations on an attribute, or equivalently a column. So you can get the average, you can get the minimum, the maximum, the sum by passing a column name or attribute name. You can, as you saw before, when you group by some attribute, you can get the aggregate values, the sum, the average for each group. So very good. That's what I wanted to show you. We just skimmed through the different relevant queries that are available in the ActiveRecord Query Interface. However, there are many more details you can read about if you look at the Rails guides. I encourage you to check on this guide, to read it. It's quite lengthy, but it's, I think, very well written and well structured. You can always look here at the index if you're looking for something specific. Yeah, of course, when you run into trouble and get errors, the most likely thing you'll do is to look first in Stack Overflow. But anyways, it's relevant that you read this so that you can have some perspective and see what is possible to accomplish with this query interface. So that's all I wanted to show you this time. Thank you for watching.